initiatives and also updates on existing endeavors. And these initiatives are not just for a search for a next refrigerant, but hopefully for a permanent solution to come. And with this, I hand over the floor to my co-moderator to introduce the first speaker.
Thank you. I have just to correct only 1 second. My name is Marco Buoni from AREA, Vice President of AREA. We said that it's an exciting session. I can not agree more. It's very exciting, and it's with pleasure that I introduce the first speaker of this session, that is Mr. Didier Coulombe of IIR. Didier has worked for the French Research Ministry, in particular as Deputy Director for Innovation and Technology Development, and he is Director of International Institute of Refrigeration, that is an intergovernmental organization that represents 60 countries in the world and represents 2/3 of the world population about refrigeration and air conditioning business. The title of this presentation will be Phasing Out HCFCs Without Increasing Greenhouse Gases Emission, Introduction of Low GWP Alternative Solution. I thanks Didier if you can stick in 15 minutes. Thank you for that. Thank you.
So, good afternoon. Assalamu alaikum. Okay. Well, I would like first to briefly introduce the International Institute of Refrigeration, then how increasing needs of refrigeration goes to increasing energy and environmental challenges, and then we will see various technical solutions, higher actions on these solutions, and then I will present you some conclusions. So, as Marco told you, well, there are some we are an intergovernmental organization, science and technology-based, promoting refrigeration knowledge and associated technologies that improve quality of life in a cost-effective, environmentally sustainable manner, including food quality and safety from farm to consumer, comfort in homes and commercial buildings, health products and services, low-temperature technology and liquefied gas technology, energy efficiency, use of non-ozone depleting and low global warming refrigerants in a safe manner. As Marco told you, we have 60 member countries worldwide, in all continents, including Middle East, and including the United Arab Emirates, 5,500 experts and 600 corporate and private members all over the world. First, our job is to collect articles all over the world, all publications, scientific publications with a review of these, the quality of these publications, and then we put them in a database, FreeDoc, with now about 100,000 references. We have journals, scientific journals, because we are a science and technology-based organization, which is the IGR, the International Journal of Refrigeration, which is has the best scientific journal in its field. Ah, yes, thank you. I'm sorry. It will be easier for me. With according to its impact factor, we have we published informatory notes, statements, and we have organized conferences, scientific conferences. I mean, we are happy to participate in these kinds of conferences, but our conferences, IR conferences, are scientific conferences with papers which are peer-reviewed and afterwards published, presented in our, especially in our database, but also in scientific journals, and thus they are, you can download them afterwards if you are an IR member. We also organize working parties. We participate in some research projects for the dissemination of knowledge, for the bibliography, and we are also involved in the preparation of some standards. Well, and as I told you, we have increasing needs of refrigeration. Refrigeration is everywhere. You have here a list of all the kinds of uses of refrigeration and air conditioning technologies. And it is very important to understand that refrigeration is everywhere, including in new technologies, information technologies, for instance. And thus, of course, here you are more involved in air conditioning, we're more concerned by air conditioning, but the refrigerant issue is an issue for all the industry, all our life. You have various reasons because of them, we will have increasing needs. We already have a lot of needs, but we will have increasing needs in the future because of the importance of refrigeration for health, because of the importance of refrigeration for everybody, and thus we have an increasing global population, especially in Africa and South Asia. We have more urbanized people. We have a lot of food losses, and also the need of air conditioning for health. We are publishing documents. I will not tell you about them, but of course the IIR is involved in this area, how to improve refrigeration for a better health everywhere and a better nutrition. And thus we have an increase in environmental impact. Well, there are two consequences. First, the energy consumption in refrigeration equipment, including air conditioning equipment, must be reduced. And I'm very pleased that we also spoke about that in the previous sessions. Our latest estimation is that we use 17% of worldwide electricity consumption in refrigeration and air conditioning, and of course more in the Middle East because of the air conditioning use. And thus we have a lack of energy resources and indirect global warming impact, which this impact is the most important one for all refrigeration and air conditioning equipment. So, of course, we cannot forget that challenge. Second challenge is the fact that most refrigeration equipment uses refrigerants, and despite of the development of alternative technologies, vapor compression systems using refrigerants will prevail over short and medium term. It is our statement, all our discussions in our organizations. Well, I will not be very long. You have here a table of the various kinds of refrigerants, and as you see, moving from HCFCs to HFCs will not have a good, if they are the current HFCs, it will have no good impact on the climate. You already know this figure with the increasing use of HFCs in the future. And we have various technical solutions. First, without any refrigerant. I heard the question before. We are also working in other technologies. We have a lot of various technologies: magnetic refrigeration, electrocaloric cooling, cryogenics, adsorption, including solar refrigeration. I'm sure it could be used in your countries. We have numerous technical developments in all these technologies. However, currently there are still problems of costs, cost of investment, efficiency, capacity of these technologies for the needs of refrigeration and air conditioning, and thus currently there are only niche technologies, but we are working on them. First, about magnetic refrigeration, we are very involved in the IIR. We organize every 2 years conferences, scientific conferences. We have a working party on magnetic refrigeration with a work on standardization, because one of the key needs at the beginning is to have more standards in that area. We are involved in a European project, Illicit, for domestic refrigeration with some international industry companies. And we need to involve worldwide users companies in these technologies, but we are working on them with some of them. We also have technologies like adsorption, including solar refrigeration. We organize co-sponsored conferences on that topic. We are involved in research and demonstration projects which are prepared now with the European Union, the International Energy Agency. We are cooperating with them. And we, of course, focus on warm countries, especially Africa, Middle East. We also are active, it is not in my slide, but in evaporative cooling, for instance, we are preparing an informatory note for decision makers about evaporative cooling. So we are very concerned by these technologies, but currently, for the next future, you will have mostly vapor compression systems. So, in order to reduce high global warming potential refrigerants in the emissions in the future, we have first to reduce leakage. It is the first step it is necessary for all the equipment, because we will not change all the equipments at the same time, and thus the main issue is to reduce leakage. It is the first step people did in other regions, for instance in Europe, in Japan. The first step is to try to avoid leakage. And there are margins for progress. We have had examples. I will not present you about the European Union, for instance. The training is the biggest obstacle. However, reducing leakage has clear advantages in terms of savings. When I mean savings, it is not only because, of course, you save refrigerants, but also you will have a better efficiency if you don't have leakage, and also because of safety. Because if you have no leakage, we have a better safety, and it is important both for natural refrigerants, for HFCs, for all the refrigerants. We published an NIR informatory note this year, presenting data and recommendations following the work of an IR working party. So, of course, please, you can download it in our website. Secondly, we can reduce the refrigerant charge. Of course, if you reduce the refrigerant charge, you will have the possibility to reduce emissions, but also you can improve the safety. Research and development does focus on all refrigerants, secondary refrigerants, microchannels, various technologies in order to reduce the refrigerant charge. We also published an informatory note this year with technical recommendations following the work of another IR working party and some IR workshops. So please think first on these issues for all the users in refrigeration and air conditioning. I would particularly mention the secondary loops, which are useful both at relatively little scale, I mean, for instance, a supermarket, but also in a larger scale, for instance, district cooling. You had a presentation about the importance of district cooling in Dubai, but it is also the fact in also important in other Middle East countries and all over the world. District cooling is certainly a good energy efficient solution, and also a way to avoid the current high GWP HFCs, because you can isolate the refrigerant, for instance, a natural refrigerant, which is dangerous for people, but it is isolated. You have people who are trained to maintain it, and thus you can have something totally safe and free for all air conditioning in your area. We also have an IR working party, and we work on the secondary loops and secondary refrigerants in the various IR conferences. And of course, last but not least, you have to choose lower GWP refrigerants as much as possible. But we need a sector-by-sector approach, and of course, it depends on outdoor conditions with particularly hot climates. Of course, all our discussions, all the presentations are in a perspective of phase down and not a phase out of HFCs, which is, of course, the state of the art of the proposals and negotiations. And thus, we still can, even if we have some evolutions in the international regulations, we still can use high GWP HFCs, but only in very limited applications in that perspective. But we have other solutions. First, with various HFCs, lower GWP HFCs. For instance, R32 is developing in Eastern Asia and would soon be worldwide available. It is simple, well-known, with relatively low cost, but it is mildly flammable. The GWP is a moderate GWP. It means that it certainly can be used in some uses, not in all of them, but if there is a phase down, it is perfectly possible to use it, for instance, in air conditioning. You also have HFOs, which are unsaturated HFCs, which have a very low GWP. We have similar uses as HFCs, but which are also mildly flammable and which are currently costly, even if probably in the future the cost will decrease. You have a lot of various blends which are developing now with HFOs, HFCs, hydrocarbons, HCFCs, which are for a lot of applications with a moderate GWP. Some of them are not flammable, some of them are mildly flammable. All these technologies with low GWP HFCs do not need many changes in equipment, but they are not drop-in solutions. You have to be careful on first the energy efficiency. Generally speaking, you can find relatively similar efficiencies application by application, refrigerant by refrigerant, but you have to choose some of them, not all of them, so you cannot simply drop in, and also because of safety issues. I mean, even if it is mildly flammable, you have to adapt your regulation, your some conditions in order to avoid any risk. We also present such technologies in our conferences on thermophysical properties of refrigerants particularly. Well, and we also have natural refrigerants. And of course, it needs different designs. It needs totally a different conception of the systems. But for new equipment, it is certainly a way you have to think about. First, ammonia. As you know, there is no problem regarding the GWP. They are very high. The energy efficiency is very high, no problem. But it is toxic. It can be ignited, and there are some problems of materials. So it is largely used in industrial refrigeration. It is possible for indirect systems, even in other kinds of systems, not only in industrial refrigeration, in order to avoid problems in public access areas. We have published another guide on ammonia. You also have CO2. Of course, people consider that CO2 is not for high global warming, high temperatures, but you have technical improvements underway for warmer climates, and we also will publish soon an IR guide on that technology. So don't forget it. You have, of course, hydrocarbons, which are flammable. Hydrocarbons are very efficient. It is certainly a very good solution for small equipment, including small air conditioning equipment. But for higher charges, you need some various technologies in order to monitor the system. And also, you have it needs a different design, a different maintenance. It is very important to train people on the refrigerants in order to avoid accidents. Well, rapidly regarding our various actions regarding all these refrigerants. We publish informatory notes and guides. You have a list of various publications we have on these refrigerants. The aim of these informatory notes is to summarize the key ideas for decision makers. There are